Great, thanks, Peter. Yeah, for those I haven't met before, I'm Naomi, and I'm going to talk about a paper called Enhancing Text Classification Through LLM-Driven Active Learning and Human Annotation. This was authored by Ruzga and McCretchy of Ontario Tech University. Ruzga completed a research master's under the supervision of Dr. McCretchy, who's an assistant professor there at the Department of Electrical, Computer and Software Engineering. And they published this last summer as part of the proceedings of the 18th Linguistic Annotation Workshop, which I wasn't aware of before, but it's an annual workshop with a call for papers put on by the ACL and the ELRA. I'm not an expert in this field, so I'll go through it at a fairly high level, but as Peter said, please jump in with any questions or comments or if I've misunderstood anything. As the title of the paper suggests, it's like broadly concerned with text classification problems, which is of course a wide spread of problems, and it doesn't attempt to limit itself much beyond that broad category. Text classification can mean many different things. You could be working with short or long form text. You could be attempting to perform like sentiment analysis or factual labeling of text. You might have a few categories you want to target or many different labels you want to apply. And it has many real world direct applications that are really important and valuable, such as the filtering of spam emails, fraud detection, sentiment analysis, and topic classification for information retrieval. It also has, I think, sort of what I'm thinking of as indirect applications, where perhaps the end goal of your project isn't to have this labeled text data set, but in having the labels on the data set, it opens up new avenues of modeling and research and analysis that you can perform with that data set that wouldn't be open to you otherwise. And it's one such problem that brought me to this paper. I found it just in a search in Google Scholar for text classification and LLMs. I've been thinking about this text classification at work in the background for a little while now. And I have a very common problem in the field, which is that I don't really have a labeled subset of my data to train a model on. And of course, there are lots of challenges inherent in labeling data for training a model. Getting a human to label text data can be expensive, both in terms of time and money, particularly if we're talking about long form text that maybe takes a while to read and understand, or if it's really domain specific, expert required information, and you're going to need someone who's a real specialist in that field to interpret and label it. More recently, we've seen the surge of generative AI, and people have attempted to use LLMs to label their data, which has been successful on the whole, but also since we're working with this nuanced natural language, there's this element of unreliability in LLM solutions that is just not there with an expert human. So there's something of a trade-off here between the reliability of the human labels and the cheaper cost of the LLM labels, and also sometimes the speed. And it's this kind of problem that the paper is situated within. It's also within the active learning field, and active learning as a whole seeks to sort of address this labeled data problem. Whereas in like traditional supervised learning methods, we'd maybe have a significant portion of our data set labeled up front and use that to train our model on according to whatever method we're using. Within active learning frameworks, instead, you seed your model with a relatively small training set to begin with. You predict using that trained model, and then you identify a certain subset of data points that would be beneficial to label and would inform your model and enable it to achieve a higher performance. So then you label those points, you append them to your training set, and in doing this iteratively over and over, you increase the performance of your model to the desired point without labeling more data points than you need to. So this is a sort of like standard approach to addressing this issue, and that's what this paper is concerned with. This general balance between the cost of labeling and reaching your desired model performance, but also this trade-off between these different methods of data annotation. And the approach that this paper takes is to use a combination of both human labels and LLM-generated labels to balance these issues. There's a third sort of like question on the table in this as well, which is, how do you identify which data points are going to be most informative to your model to improve its performance in this active learning framework, in this sampling step? There are many different existing methods of sampling within active learning that might be more or less appropriate in different situations, but this is another problem that the paper touches on. And in terms of the solutions that are already out there, the authors highlight that LLMs have already been used in a paper in what's called a cold start active learning problem, where we don't have any initially labeled data, and it was used in like choosing the data points to label in that framework. They highlighted another paper where an LLM annotator was used in active learning in that data annotation step, and one where human and LLMs were used in combination in a collaborative learning approach, I think more of an unsupervised situation. So there's some precedent, but it's coming in this new space where we're using this combination in an active learning framework. So the methodology that they lay out is to compare this suite of different data annotation methods in an active learning framework applied to 3 different data sets. And they're interested in comparing the cost and the model performance because they want to achieve that balance between the two. So they calculate the cost of running the models using LLM and human annotation pricing models. I think the human annotation model that they used was that of Google Vertex AI data annotation service. And so they used like the token rate applied to their problem. And they use F1 scores for the model performance at each step in the active learning process. They run each method twice, once with a random sampler to determine which data points to target for labeling, and once with uncertainty sampling. So they're using a logistic regression model as their base model, which is outputting probabilities for the labels that they have to work with. And they rank these and then choose the most uncertain ones to label. They begin with 2% of the training of the data set labeled as a training set to initialize their model with. And then they incrementally add 0.2% of the data set each iteration in active learning over 250 steps up to 52% of the data set by the end of the process. They work with 3 different data sets that were chosen. I think they're fairly sort of standard in this field, and they cover a fairly broad range of use cases by doing this. The IMDb reviews data set includes reviews of movies, given one of 2 different labels indicating it's a positive or negative review. So it's a sort of sentiment analysis based data set. They use a fake news data set, which includes longer form pieces of text that are news articles with, again, 2 labels determining whether it was factually accurate or not. So sort of authenticity discernment. And then finally, they use a movie genres data set, which includes descriptions of movies assigned one of 4 different genre labels. So a multi-label classification data set. And they chose these ones as well because they're fairly balanced. So there's a roughly equal number of data points in each label category. So it's not going to be biased towards one. There's like, I think, a question about whether that's realistic or not, because in real life, you're rarely going to have a balanced data set. And in many text classification problems like fraud detection, it's going to be very skewed where you have overwhelmingly authentic documents and then a small number of fraudulent documents that you want to identify. But for the purposes of evaluation, it's helpful that it's even. They split each data set into different pools throughout the process. So they have the labeled training pool, which moves from the 2% to the 52% of the data set. And then in the sort of unlabeled set, they have the standard unlabeled pool, but also a proxy validation pool, which is 5% of the data set. And this is used to sort of, it's used as like a proxy test set, because of course in real life you wouldn't be able to measure your model performance on the entire rest of your data set, because by definition it's unlabeled. So in doing this, they can sort of check that their performance calculated on the full unlabeled pool is also representative of how the active learning process would progress if someone was using this method in real life, and using that as a cutoff for their model. For each data set, they apply a few different labeling techniques, which are used in different ways by different methods, which I'll get to next. First of all, there are human labels. So these are the labels that are already present in the data set and were assigned by humans. They assign some new labels using LLMs. So they prompt an LLM to generate a label for each data point in the set, and also to return a confidence score for each data point along with it. And this should just like indicate how certain the LLM was about assigning that label to that data point. And finally, they apply some few-shot LLM labels to the data points that were below a certain confidence threshold. So where the LLM wasn't very certain of these labels, they reprompted, including a few examples using human annotation of what actual labels in those categories should be. And then they reprompted it using that. So they had sort of like a second LLM pass for some points. So they have this like small suite of methods that they're comparing. And as baselines, yeah, we've got a question.
Oh, one thing I was wondering is, so for the LLM labels, they would, what is it, they would prompt it to output like a number as well, saying like, give me a number out of 10 to tell me your confidence?
Yeah, exactly. So they go for like a percentage, I think. So, and the thresholds at which they're switching to few shot, or which they calculate few shot as well with the LLM, depends on the data set. So they were kind of targeting a certain percentage of the data set with the few shot approach. But yeah, so they return the confidence score with the label from the LLM. Yeah. Is there anything else to say here? I don't think so. Oh yeah, the LLM that they're using throughout this is GPT 3.5. So they have two baseline methods to compare their hybrid approach to. One is once they've selected the data points to label, they just assign the human label to all points and append those to the training set. And they have another baseline where instead they assign all LLM labels to the data points. But they also introduced the hybrid method. So once they've got the points that they want to label, if the LLM's confidence score for that point is above a certain threshold, then they use the LLM label. But if it's below, if the model wasn't certain enough about it, then instead they assign a human label, and then they append those labels to the training set. So this is almost like another filtering stage in that active learning process, where you've had your initial sampling of data points based on the model's certainty, and then now we've got another level based on LLM certainty in an attempt to balance the quality of human labels with LLM labels and the cost. And then in the few-shot approach, it's kind of similar, but whereas above a certain confidence score, they use the one-shot LLM labels. Instead of using the human labels below that threshold, they use the few-shot LLM labels. So where it's had another go based on some examples. So this is the sort of suite of methods that they're using. We've got these two baselines. For the first hybrid approach, they use 3 different thresholds that they test: 70% confidence, 80%, and 90%. And then for the few shot approach, they just run that once. And as I mentioned before, that confidence threshold depended on the data set that they were using. So I'll show some of their results next. Generally, they found across all of the different data sets that the hybrid human and LLM approaches provided a balance between cost and model performance. Generally, the higher the confidence threshold used, the better the performance, but of course also the higher the cost because you're including more and more human labeling. So on the right, we see one of their figures showing the evolution of the model performance over the course of the active learning lifecycle, going all the way from using 2% of the training data on the x-axis at the very start up to the end of the process where they've moved up to 52%. And on the y-axis, we have the F1 score. And each different method has a different label using either the uncertainty sampling or the random sampling. The two best performing ones in pretty close alignment were the human labeling and the GPT greater than 90% labeling. So yeah, the more human labeling, obviously the higher the quality model performance, but quite interesting that they were so closely matched. And then in this particular data set, the rest are kind of a fairly closely matched pack, with maybe the confidence greater than 80 having a notably higher performance like in between the two. And then if we shift to, yeah.
One thing I think is interesting about the plot is you could also clearly see like the difference between uncertainty sampling and random sampling. It seems like there's a 10% bump there just from doing that.
Yeah, absolutely. If I go ahead here as well, that was consistent across all of the different data sets. Yeah, you can really see it starkly. So yeah, this active learning framework with whichever method you choose seems to perform better than a traditional supervised learning method with the same model. So you're achieving a greater model performance with fewer data points. So that was really cool. Yeah. Yeah. In terms of the cost performance trade-off, they also included these plots for each data set. So we have the F1 score on the x-axis and the expense with an exponential scale on the y-axis. And again, each model goes through from 2% up to the final 52% training data F1 score. And you can see the spread really clearly here, where like the human only has a similar performance to the GPT-90 version, but there's quite a notable drop in cost, particularly with an exponential scale. And this continues down with the different confidence thresholds used. So your model's costing less and less, but you're getting this slight drop off in performance. It's still greater than 0.9, but you know, obviously if you want to squeeze out these last percentages, maybe you want to pay for the more expensive version. Yeah, Peter.
One thing I thought was interesting about this plot is like for all the lines up to the 90%, there's this like dip where you pay more, but your F1 score gets less.
Yeah.
I was wondering what was going on there.
I was also curious about that. Yeah, I'm not sure. Yeah, I'm not sure. I'm curious. I was just gonna have a look and see if it was also present in the random sampling, like maybe if it was to do with the points that were sampled or something. Yeah, I'm not sure. I think some it's lesser than others, and obviously there's going to be some up and down, whatever. But it was particularly noticeable for the few shot, albeit I think it looks a bit stretched out on this plot because of the exponential y-axis. So maybe it's more random variation if we look at the regular y-axis. Yeah. But yeah, and I thought it was interesting that the few shot and the GPT only methods both achieved fairly similar F1 scores, and both obviously cost very similar because there was very little human annotation. or negligible human annotation in the few-shot approach. But in other examples, like such as on this data set, so this previous one was the fake news data set, and this one's the movie genres data set. And here the model performance, it does reach a much higher level for the few-shot approach, demonstrating like the few-shot learning capabilities of the LLM. So that was kind of cool. That said, this was the movie genres data set where there were 4 possible categories to assign the data points to. And universally, the performance was worse in this multi-classification problem compared to the fewer labels, which I guess makes sense because it's a more complex problem. But yeah, that was kind of interesting. The F1 scores were consistently lower, and there was a bigger spread between them as well. So again, when using in real life, it might be something to factor in. We've talked about the uncertainty sampling. Yeah, the last result they kind of showed was that the F1 scores throughout the process for the proxy validation pool and the unlabeled pool were in really good alignment, indicating that the method would give a similar like indication of when you can stop training if you're using it on a real world problem with a smaller labeled set than this fake case where you have the F1 score on the whole data set. So that was cool. Again, obviously, this was on like a balanced data set, and there's all kinds of caveats that maybe it would be different in real life. But finally, they didn't really give like a table or a figure for the overall accuracy of the LLM results, but they had a few numbers in their results section that I've just pulled out into a table here. So for the 3 data sets, the percentage of correct LLM labels with the one-shot approach was 89% for IMDb, 73% for fake news, and 66% for the movie genres dataset. And then the confidence threshold in the LLM that the LM gave, that gave 50% correct, like it dropped down to 70, 80, and 80. So I feel like I haven't described that very well. Basically, below that threshold that's given here, 50% of the LLM labels were correct and 50% were wrong, roughly speaking. So my takeaway is kind of that the confidence scores are a generally good indicator of label reliability. Yeah. So in conclusion, I feel like they showed the goal of like the viability of this hybrid human annotation and LLM annotation approach in active learning. There was this really clear trade-off between the model performance and cost, and you could, I think, feasibly choose an approach that would fit your constraints best. I'm really curious about the possible impacts of varying different elements in the experiment. Obviously, they kept it all the same for consistency, but I'd be interested to see how this worked with different LLMs. We've made huge progress, obviously, in generative AI in the past couple of years. And different LLMs have different strengths and weaknesses, as well as just overall better performance. So if you've got a classification problem with really short snippets of text, I guess that might influence what kind of LLM would be best to choose here. I'm curious about the sampling method. We saw the impact of random versus uncertainty sampling in this, and the consistency across all models of the improvement from uncertainty sampling. But I'm curious as well if like different sampling methods would highlight different kinds of data points to highlight, and that might have an impact on the benefit of the LLM versus human approach. I was also curious about the step size used in active learning in this framework, because they used it evenly across the whole process, which makes sense. But I was curious about things like, what if you had like a larger step size at first and just focused on the LLM confident results then, and then added a human annotation element later on to squeeze out better performance at the top? I feel like there's lots of different variations on it you could do, and it'd be interesting to see the impact of those. They used fairly simple and straightforward prompting for the LLM, which I think makes sense. But I'd be interested to look at different like prompt engineering around this, and particularly with the few shot approach and the examples given. And maybe there's something to be learned about like the number of examples given in the few shot approach. I was also kind of curious about the selection of a threshold for the few shot approach, because it was chosen so that a certain percentage of the data set would be annotated in this few shot approach. And I don't know, I'm not sure that that's like the best way to determine that. Maybe there's other ways to determine it. And in general, I was kind of thinking when I first read through the paper that it would be an iterative process where in each step of the active learning, you would be reprompting the LLM with new examples rather than this static set of one shot and few shot labels. And I think maybe, I don't know, if the LLM had a smaller set to work with in each iteration, that could maybe provide a better result. Yeah, the code they've made available on GitHub, they have a bunch of different notebooks where you can play around with these methods, along with like CSVs of the data that you can use. Yeah, are there any questions?
One thing that, so one question I had, I just thought of it now when you're talking, is like, when they're in this framework, when they label another 0.2% of the data set, do they retrain the model on all of the labeled data?
Yeah.
Or just that, oh, okay.
Yeah.
And do they train it from scratch, or do they train the current, train it off of the current model?
Good question. I'm not sure, actually. I'm not sure. I don't think they mentioned that in the paper, but probably you could tell from the notebook.
Yeah, I think if they did it off of the trained model, it would be called, they would call it like continual learning.
Okay.
I'm just guessing here. So probably it's like each time they label data, they train an entirely new model. Oh, Arvid, do you know?
No, I don't know. But I had a question along those lines. There used to be a company, I think they still have it, Snorkel. And what they would do is essentially have human annotators try to give features, and then they would use the features to relabel the data set, and then find those where the uncertainty is highest, and it gets back. Is it possible to do something similar here as well? But so essentially, I don't know, for the few shot learning, do you give different prompts that is sort of, you ask human labelers to devise sort of queries that would help the LLM to sort of get to the salient part of what makes a text in particular work for a particular problem?
Yeah, that would be really interesting. I thought as well, like, you could maybe it's maybe it's unrealistic, but like with the few shot approach, you could almost leave out the active learning element, right? And just have it as sort of like a semi-active learning approach for labeling the whole data set, where you continually reprompt the LLM until you're more and more confident in the labels it's giving, and use that as a labeled set. But I think I didn't understand probably the first part, the first example you gave with Snorkel, was it?
Yeah, Snorkel. Was a paper, I think, a couple of years ago, and then they spun it into a company. It's essentially like, how to derive features from human interactions, and essentially classify also which features are better than others.
Yeah.
Which then also feeds back a little bit into which human experts were better than others. So that would, so essentially it was a methodology that gradually would improve your data set clarity. And I wonder whether there's a way how to do something similar like that with these bigger language machine learning. Essentially, like a knowledge transfer from human to machine that goes maybe beyond.
Yeah, absolutely. Yeah, and again, that comes back to them using this like static LLM labeling approach, where they've done
just
it
the labels
once
itself
at the start. But yeah, if each time you could define certain guidelines in your prompts for the LLM from a human basis, then that would be really interesting to see the improvement each time using the reprompted LLM afresh each cycle. Yeah.
Cool, thank you. Very interesting.
Great.
One thing I was thinking is that, so were they retraining? They weren't. No, they couldn't have been training Chat GPT-5.
No.
They must have had like some other LLM that they were doing it for, right?
What do you mean?
Like they must have been training some other LLM in order to do the classification, not GPT 3.5.
What they just asked it to return a label and a competence score each time. They didn't do like retraining.
But the text classification, right? That like they had some text that they had to use a language model to process and then classify.
Yeah.
So what was the model that they were training actually?
A logistical regression model. Yeah.
Oh, so it was just, and the input was like the embedding from GPT 3.5.
Yeah, I'm not sure what embedder they used. I was also thinking about that a bit in this element, right? About varying the different elements and like the impact of maybe a different embedder. But I'm not sure if it would actually change much for the actual methods themselves, if they're getting the raw text.
I was thinking that probably this is really cool, but like a more widely applicable area of research would be, which you mentioned, is like maybe you have a very small labeled data set and you try to use it to come up with like a prompt for classifying using like a proprietary model that works best. And maybe also you have some kind of data selection so you can put few shot examples in as well, like basically configuring all of it so you get the best out of your proprietary model.
Yeah,
that would be a cool experiment to see like how you would choose data and how you'd prompt it.
Yeah, absolutely. Yeah. Yeah, Vikram.
Hey, thanks for the talk. And I don't want, this is a general question, it's more philosophical one, rather than I want to keep it at the end because I don't want to put anyone on a downer. But like, it's more like, I mean, do people remember like the Twitter files a couple of years ago, you know, where there was censorship revealed like in Twitter in terms of political speech and stuff?
Right.
A couple of years, but anyway, and now currently, you know, we've had two minor social media platforms quitting the UK, Gab and BitChute, because of the government's request for user data. You know, they don't want to comply with that because, you know, and we've also seen social media users in the UK locked up for things they posted online. You know, so, you know, when talking about free speech, do we have free speech in the UK? But I'm going off on a tangent. But I'm just saying, do the social media platforms that comply with, you know, for example, UK government requests for what users are posting, are they using LLM models? Do you think?
Are they using LLM models to
I guess
identify
to crawl their, you know, user content, to identify text, to classify text, and then, you know, I guess building a profile of potential users who are posting wrong thing?
I really don't know. I think my understanding is there's certain keywords commonly used on different social media platforms, varying by platform, right, that are used to flag content. But I'm not sure if they're doing a whole text classification on tweets and stuff. I imagine it would be quite computationally expensive given the volume. And I think
So
probably
it's just text, it's just keywords rather than LLM.
I'm not sure. Yeah.
Okay.
I'm sure they have some algorithm, which I guess inherently must be some kind of text classification algorithm, but I'm not sure the complexity of it. Yeah.
Okay, thanks for allowing me to vent that.
Yeah, but if anyone else does know, please chime in because I'm not sure.
I'm not sure. My best guess would be like, no, not yet, but probably in the next couple of years, definitely.
Yeah. Certainly it feels more and more feasible with LLMs getting cheaper and cheaper, and yeah. Cool.
Thanks.
No, great. Thank you for your questions. Awesome. Do we have any more, or shall we wrap up there?
I'd say let's. It seems like we have one more.
That's a really quick question. That's a great talk, by the way. Thank you so much.
Thanks.
So this is being used to train a logistical regression model. So, did they look at how good the LLM itself was at generating labels, and compare that versus the output of the model they trained?
Yeah, they didn't compare it directly to the output of the model, but I think the best proxy would be this set of they didn't provide a proper breakdown, I guess, but per data set we have the rough percentage of correct LLM labels. Yeah, so the majority of labels were correct across all data sets, but particularly high in the IMDb one. And again, with the confidence threshold given by the LLM roughly correlated with the reliability of the label as well, what percent were correct in that category.
Yeah, it's fascinating looking at the graph with the percentage of training data versus the F1 score.
Oh yeah,
using the GPT only ones, it goes up to sort of over 0.9.
Yeah,
GPT as a training source. It suggests that GPT is actually very accurate.
It's already really helpful.
Really accurate, and maybe you should just use that instead of training up the second model for this. But
yeah, I think certainly if cost is a big factor for you, and obviously another thing that's not really mentioned is the I guess inconvenience of human labeling. And obviously there are human annotation services like Google's, and I think is it Mechanical Turks for Amazon. But maybe if it's particularly expert stuff, you want a particular in-house expert or someone to use their time for labeling. So there's another aspect of the time involved, I guess, if you don't just have a handy API that you can integrate and get humans to annotate that way. Yeah. So yeah, but yeah, I think it's really cool, the trade-off, because yeah, as you say, the GPT one is already at least in this this 2 category use case is already really good, right? And then maybe you care more if you've got a multi-label thing, you're going to shell out for more human labeling, perhaps.
That's a good point. Awesome. Thank you.
Thanks for your question.
Cool. I think we'll end it there.
Great.
Thanks for the presentation, Naomi.
No, thank you all for your questions and for coming. Yeah. Have a good afternoon. Thanks.
Bye.
Thank you.